Hello everyone. In today's lecture we are going to discuss about the data structure stack and the memory representation of stack. In the previous lecture we already discussed about what is meant by data structure and the types of data structure. And so in this lecture we are going to continue the stack data structure and then we discuss the memory representation of stack. So let's start from what is meant by stack. So stack is a linear type of data structure. It is a linear type of data structure. That means the elements which are stored into the stack in a continuous memory locations. The elements are stored into the stack in a continuous memory locations, and that's why it is called as a linear type of data structure. Also, stack follows the last in first out principle, LIFO. That means last in first out. LIFO means the last in first out. That means the element which is inserted last will be removed first, or we can say that the element which is inserted first will be removed last. For example, let's take the real life example. For example, these are the stack of books. This is a book 1, then this is a second book, then third, and then fourth. For example, these are the 4 books which are placed one above another. So if we want to remove the second book, then first we have to remove the 4th book and then the 3rd book, and then it is possible to remove the second book. So this is a real life example of the stack. So in this way the stack also works. Stack means it is a linear type of data structure, means which store the elements in a continuous memory locations, and stack follows LIFO principles. That means last in first out, means the element which is inserted last will be come out first or will removed first, or the element which is inserted first will removed last. Stack has only one pointer and that is called as a top. So insertion and deletion of element are performed from only one end, that is called as a top of the stack. Let's see the actual definition of stack. It is defined as a container in which insertion and deletion can be done from only one end, known as top of the stack. So this is the actual definition of stack. What is meant by stack? It is a container in which insertion and deletion can be done from only one end, known as top of the stack. So stack has only one pointer, that is called as a top, and insertion and deletion can be performed from the same end, that is called as a top of the stack. Okay, let's see the representation or working of stack in a memory. So logically stack can be represented like this. So stack has only one open end. As you can see, this is an open end and this is a close end. So stack has only one open end and that is called as a top of the stack. As we seen earlier, the definition of stack, it is a container in which the insertion and removal can be performed from the same end, and that is called as a top of the stack. Now here the stack is empty. Let's consider the stack is empty. So the value of top is equal to -1. Always remember this thing, that whenever the stack is empty, the value of top is equal to -1. When we insert element into the stack, we increase the top pointer, and when we remove element from stack, we decrease the top pointer. So top is a pointer and which points the topmost element of the stack. So this is a logical representation of stack. Now let's consider we have an array, for example integer a of 5, let's say 5 elements array, and the elements are 5, 8, 12, 15 and 27. This is an array and we have to insert these elements into the stack. Here the stack is empty, so the value of top is equal to -1. When the value of top is equal to -1, then we can consider that stack is empty. Now first we have to insert the element, that is 5. So here we insert element, that is 5, and Now the value of top is -1, so we have to increment it by 1. So now the value of top is equal to 0. Again, the two most important operations of stack are push and pop. Push means inserting element into the stack and pop means removing elements from the stack. So whenever we have to insert element into the stack, we use push operation, and whenever we have to remove element from the stack, we use pop operation. We see both the operations in detail in the next lecture. So first we have to understand the working of stack or the memory representation of stack. So the first element is inserted into the stack, that is a 5, and then we increment the value of top. So top is equal to -1, so it is incremented by 1, so value of top is equal to 0. Now again insert the second element. So already we have in a stack 5, and then we insert the next element, that is 8. So here the value of top is equal to 0, so again it is incremented by 1. So top is equal to top plus 1, that means 0 plus 1. So the value of top is equal to 1. Okay, the next element we have to insert is 12. So here in stack already we have 5 and 8. Now we have to insert the element 12. So we have to increment the top pointer, and here top pointer is incremented by 1. So top is equal to top plus 1, that means top is equal to 2. And here we insert the element 12. Now again, each time whenever we insert element into the stack, we use the push operation. Remember this? Okay. Now we have to insert the element 15. So again, the stack is 5, 8, and here is a 12. Now top is pointing to the topmost element, that is a 12. Now increment the top by 1. So the value of top is equal to 3, and insert element, that is 15. Now top is pointing to the 15 because in stack top is always pointing to the topmost element of the stack. Now again insert the last element. So already we have 5, then 8, then 12 and 15, and top is pointing to 15, that means the value of top is equal to 3. Then increment top by 1. So here the value of top is equal to 4, and insert the element, that is 27, into the stack. In this way we can represent the stack into the memory. So here we have 5 elements array, and when the stack is empty, the value of top is equal to -1. Top means a pointer. Top is a pointer, and insertion and deletion can be performed from the same end, that is called as a top of the stack. Again, stack has only one end, that is called as a top. When the stack is empty, the value of top is equal to -1. When we insert element into the stack, we have to increment the top value each time. We have to increment the top by 1, and when we have to remove element from the stack, then decrement the top by 1. So here we call the push function 5 times. We can say that for 5 elements. First time we insert element 5, then 8, then 12, then 15, and then 27. For example, we have to remove the element from the stack. If we want to remove the elements from the stack, then first we have to remove the last inserted element, because the principle of stack says that last in, first out. That means the element which is inserted last will be removed first. So if I want to remove the element from the stack, the top of the stack, top is equal to 4 and top pointing to 27. So we remove the element first, 27. Then the top is decremented by 1. That means top is equal to top minus 1. So the value of top is 4, 4 minus 1, and that is equal to 3. So now top is pointing to 3. Okay, now we have the top is equal to 3, the topmost element is 15. Again we call the pop function. Pop function means to remove the element from the stack. Again we remove the topmost element, and topmost element is 15. So again value of top is decremented by 1. So top is equal to 2. Again, we remove the topmost element, we call the pop function. So here 12 is removed from the stack, then the value of top is decremented by 1, so top is equal to 1. Again, we call the pop function, we have to remove element from the stack, so remove the topmost element of the stack, remove element 8, so the value of top is decremented by 1. Now the value of top is equal to 0. Again, remove the topmost element. Now our stack is empty, so the value of top is equal to -1. So in this way we can represent stack into the memory, or this is a logical representation of stack, we can say. I hope you understand. If you have any doubt, then let me know in the comment section. Thanks for watching.